Good morning, students. In today's class, we are going to solve some questions from exercise 5.4. Now, these are questions where we have made use of the exponential function, the log function, and also the inverse trigo function. So, keeping in mind basic derivative results, chain rule, derivatives of inverse trigo functions, derivative of composite functions. So, we are going to use all this to solve the questions. So let's start with exercise 5.4. Okay, so I'm going to start here with the second question. The second question is e to the power sine inverse x. This is what I'm going to call y. So we are differentiating with respect to x. This is what we get on the left hand side. On the right side, you must have identified that this is an exponential function, but the power is not x. Hence, this is a composite function. So what will you do? You will differentiate the exponential function first, and you know whenever you differentiate exponential function, you get back the same function. Next step, you are going to differentiate its power with respect to x. So if you remember the standard results, derivative of sine inverse x is 1 upon under root 1 minus x square. So finally we are getting e to the power sine inverse x upon under root of 1 minus x square, which is equal to dy by dx. So next let us try question number 4. So y is sine tan inverse e to the power minus x. You again see that this is just not the sine x function, so that means it's a composite function. So how many functions do we see here? There's a sine function, then tan inverse function, and then composite exponential function as well. Alright, so finding out the derivative one by one. So what we do first is we differentiate the sine function. So derivative of sine is cos. We have differentiated sine function. Next, what will we do? We will differentiate the tan inverse function. Okay, so doing it stepwise, tan inverse e to the power minus x. Now we know the standard derivative of the standard tan inverse function is 1 upon 1 plus x square. That means this term comes here. So accordingly, this should be 1 upon 1 plus square of e to the power minus x. So that way we have differentiated the tan inverse function. Now the last part that is left is to differentiate e to the power minus x. So cos tan inverse e to the power minus x upon 1 plus square of this would be e to the power minus 2x, right? And then derivative of this. This is again not a standard exponential function, but the moment you differentiate exponential function, you get this, and then you differentiate its power. When you differentiate its power, you get minus 1. So that minus sign I'm going to put here in front. Then I'll write down here the exponential function, then the cos function, and then the denominator. So this is the derivative of the required function. So next let's try question number 6. It is e to the power x plus e to the power x square and so on till e to the power x5. Okay, so here I will just write down all the terms which are missing from here. Only 2 terms basically. It is this. Now next step, let us differentiate. So we are going to differentiate all the 5 terms one by one, differentiating the first term. So let me write down like this: derivative of first term, derivative of second term, and the derivative of the other terms. Alright, with respect to x. Standard exponential function, so we get back the same function. Here this is a composite function, so we'll get back the exponential function and then we'll multiply it by the derivative of its power. So if I'm doing this step only, this is 2x e to the power x square. Now moving on to the third term, exponential function which is composite, so e power x cube, again differentiating x cube, we get 3x square e to the power x cube. Likewise here, e to the power x4 multiplying by derivative of x power 4, we get 4x cube and the exponential function. And the same thing we do for the last term as well. So we get here 5x to the power 4 into e x to the power 5. So this way we have got the answer. Now if you look at this solution, there is a logical error in this solution. Your answer may exactly match with what is given at the back, right? But there is a logical error. What is a logical error? Let's look into that. If you look logically, the first expression is equal to this expression. Now think logically and decide, is this expression equal to the next one? It is not, right? Because here you're writing an expression and the next step you're finding out the derivatives. That is why it is important that in all such questions we give a name to the function, some expression that is called y. This is the same expression, it is called y. Now in the next step, what have we done? We have differentiated. So here comes dy by dx. And then what follows here is again the derivative. And in the last step, we obtain the final derivative. So if the left side is not written and you're putting equal to signs, even if you don't put equal to signs, simply write down this expression, because there is logical error. You may not be able to score full marks in such a question. So be careful about that. So next we are trying out here question number 9. We are given cos x upon log x when x is greater than 0, right? This is for the log function here. And again, let us call this function as y. You can see a function divided by another function. So we are going to use here product rule. So let's write down the product rule first. Log x into derivative of cos x minus cos x into derivative of log x upon square of the denominator. So here log x, derivative of cos is minus sine function, right? It's a standard cos function. Then minus log x, derivative of log x, this is base e only, so it is cos x upon x. And then in the denominator we have log x whole square. So you can leave it in this form. If you want, you can take a minus sign common. You want to take LCM. If you want to take LCM also, we can do it like this: x log x sin x plus cos x upon x log x whole square. Okay, so this is how the question is done. The last question from this exercise, 10. Y is equal to cos log x plus e to the power x, where x is greater than 0. You can see it is not just a cos function, simple cos function, so it is a composite function. So let us once again differentiate it using chain rule. Differentiating cos function, we get minus sine log x plus this. So cos function we have differentiated. Now we are going to differentiate this term in the brackets. So that is log x plus e power x. So we get minus sine log x plus e to the power x. Here base is e, so derivative of log x 1 upon x. Here the derivative is e to the power x. You can leave it in this form. If you want, you can take LCM, rewrite the terms. So this is how we have done few questions from exercise 5.4, and I think you should be able to solve the remaining questions.